Hello everyone and welcome to our water quality presentation. The effects of alkalinity and acidity in drinking water. Alkaline refers to part of the pH scale which is from 0 to 14. The lower numbers are more acidic while the higher numbers are more alkaline, with 7 being neutral. Alkaline water results from dissolved limestone or dolomite minerals in the aquifers or water bodies. Effects of drinking alkaline water. Drinking a bottle of alkaline water daily will not significantly affect your body, but too much alkalinity may also agitate the body's normal pH, leading to metabolic alkalosis, a condition with the following symptoms: nausea, muscle twitching, vomiting, confusion, and hand tremors. For people with kidney disease or those who are taking medication, drinking alkaline water could possibly have negative side effects. Treatment of alkaline water. Alkalinity in water can be reduced by installing a chemical feed pump that injects a weak acid solution. The second treatment method can be boiling the water, which will evaporate some of the minerals causing the alkalinity. Acidity in water. Any water with the pH levels below 7 is considered acidic, above 7 is considered basic, and at 7 is deemed to be neutral. Causes of acidity in water. Due to industrial pollution, with low pH water often being found near mining sites or chemical dumps. Some causes are due to natural phenomena such as acid rain. The effects of acidity in water. Consuming acidic water exposes the body to heavy metals and minerals present in the water. The exposure may lead to sickness or poisoning. Another effect is that drinking acidic water damages the teeth over time by corroding them, and it also damages the gums as well. Treatment of acidity in water. Soda ash or sodium hydroxide. The soda ash and sodium hydroxide raise the pH of the water to near neutral using neutralizing filters. However, this method causes water hardness problems. The contamination of groundwater. Groundwater is the water present beneath Earth's surface in soil pore spaces and in the fractures of rock formation. This water is safe to use. However, groundwater sources become polluted with germs such as bacteria, viruses, and parasites, and chemicals such as those used in fertilizers and pesticides, which can in turn make people sick. Sources of pollution, or how groundwater gets polluted. This occurs when man-made products such as gasoline, oil, road salts, and chemicals get into the groundwater and cause it to become unsafe and unfit for human use. Toxic substances from mine sites and used oil also may seep into the ground, thus entering the water source. Prevention of groundwater pollution. By properly disposing waste and not dumping chemicals down the drain or on the ground. Test underground fuel tanks for leaks. Minimize the use of chemicals and always use according to directions. Treatment of polluted groundwater. Pump and treat is a common method for cleaning up groundwater contaminated with dissolved chemicals using industrial solvents, metals, and fuel oils. The water is extracted and conveyed to an above-ground treatment system that removes the contaminants. The prevention of groundwater pollution. Groundwater pollution can be prevented by not dumping chemicals on the ground. Another prevention method can be to check for leaks of underground fuel tanks. Another one could be to minimize the use of chemicals and always use according to directions.
Ozonation. Ozone is the triatomic form of oxygen, which is composed of 3 oxygen atoms. When UV light hits oxygen gas, it breaks it down to 2 oxygen atoms. Then when an oxygen atom meets oxygen gas, it forms ozone gas. Because ozone is unstable and cannot be stored successfully, it must be generated at the point of application by ozone generator. The process is carried out by an electric discharge field as in the CD-type ozone generators or by ultraviolet radiations as in UV-type ozone generators. In the ozone generator, oxygen molecules, that is O2, are split into individual oxygen atoms. In this state, oxygen is very unstable, so it joins with other oxygen molecules to form O3, which is ozone. The raw water is then passed through a Venturi injector, which creates a vacuum and pulls the ozone gas into the water, is then bubbled up through the water being created. After injection, the ozone must have time to do its work. This time is known as contact time. Contact time is the time ozone has to oxidize and disinfect, or the time the water is allowed to hold the disinfectant. For ozone, contact time is measured from the point of injection to the filter. The contact time needed varies with the matter to be oxidized. Since the ozone will react with the metals to create insoluble metal oxides, post-filtration is required. The water is pumped by the pressure tanks to the automatic filtration system. The post-filtration process is performed by an automatic filtration system. After the water gets post-filtered, when it is fit for the household purposes and clean, filtered water is supplied to houses.
In this part of the video, we will be discussing about the chemical processes involved in wastewater treatment. Chemical methods of treating wastewater uses the chemical characteristics of the pollutants. It takes advantage of their tendency to react or interact with the treatment chemical, and it also uses the chemical characteristics of the products of the reaction between the pollutant and the treatment chemical. It takes advantage of the solubility, the volatility, and the suspension of the products. These are the most important implemented chemical processes used in wastewater treatment. Ion exchange. Ion exchange is a reversible reaction in which a charged ion, which is unwanted in the wastewater, is exchanged with a similarly charged ion, which is electrostatically attached to an immobile solid phase. The implementation of this method is for softening of the water. This method is suitable for removal of heavy metals and anions. Polyvalent cations are exchanged with sodium. The wastewater is introduced to a bed of resin. In the solution, the sodium is exchanged with the cations. The water is also introduced to a basic resin to remove the anions in the water. This method is for controlling or adjusting the pH. The pH of water should be kept around 7. A pH lower than 7 favors the toxicity of heavy metals, and pH above 9 transforms ammonium into dangerous soluble ammonia. This is an example of a neutralization tank. As the wastewater enters the neutralization tank, it is stirred completely. This is to ensure that the contents in the tank are uniform throughout the tank, so that when the pH monitor measures the pH of the water, it reads a value that is corresponding to the contents that are presented inside the tank. If the water is acidic, then a base is added to neutralize the acidity and adjust the pH to acceptable range. If the water is basic, then an acid is added to neutralize the alkalinity of the precipitation and flocculation. These two methods are similar and they work hand in hand. The difference is that in precipitation, we remove dissolved inorganic materials, for example, heavy materials, and in flocculation, we remove very fine particles that are present either suspended or in the form of colloidal suspension. In the first step of both the methods, a coagulant is added. In flocculation, we use ammonium or iron salts. Then the coagulant forms a precipitate which traps the impurities that settle down to the bottom, which can then be removed by sedimentation, filtration, or other solid removal process. This picture shows the effectiveness of precipitation and flocculation on the wastewater treatment. Chemisuption. Chemisuption is a method whereby chemical bonding binds substances to the surface of a solid body. This method uses activated carbon to bind soluble water contents that could not be sufficiently removed by other methods like precipitation, flocculation, ion exchange. This method removes a wide range of organic materials like colorants from textile dyeing plants and anthropogenic trace elements. It can also remove arsenic and heavy metals. Disinfection. This is the last step of wastewater treatment, whereby chlorine is added to inactivate pathogens and to also ensure that the water meets the wastewater discharge standards. Chlorine is not the only disinfectant that can be used. There are other disinfection methods, for example, ozone and UV light. Well, that's the end of this video. Thank you for watching. Don't forget to be water wise. Hope you have learned something about wastewater treatment and how water is cleaned to ensure that it is safe for us to drink. Be water wise.